All right, lesson 45. We only have 2 more lessons and then your review and then your final. So as of right now, I will have posted for next week review problems and the answers and how I worked them out and our final review. We can figure out maybe a way to kind of go over them, not just have you like seeing the problems, okay? But you have 2 more lessons to get through. So 45 and 46. 45, we are using f prime, so we're using the derivative of our function to find maximum and minimums, and then other characteristics of our function, okay? So you know that a function is increasing or decreasing on an interval if every greater value of x, right? So it's increasing, right? You know it's increasing if as x gets bigger, your function is getting bigger, okay? Or, you know, it's decreasing if as x is getting bigger, y is getting smaller, or the function is getting smaller, okay? So we would say then that a function is increasing on an interval I. If the function evaluated at the first value of x is less than the function evaluated at the second value of x whenever x1 is less than x2 in your interval, okay? It's just a way of saying the y is smaller, the first y is smaller than the second y when the first x is smaller than the second x. Okay, and decreasing is just reversed. So the function at the first value of x is greater than the function at the second value of x when the first x is less than the second x. So it's just saying as you move along the x-axis, if it's increasing, then the y is getting bigger. Decreasing, as you move along the x-axis, the y is getting smaller. Okay? We kind of already knew that from algebra, right? You know how to look at something and decide if it's an increasing or decreasing function. But in calculus, we can often use the derivative to check to see if a function is increasing or decreasing. Okay, some functions aren't like a straightforward function, so it's not as easy to decide by using this definition. Okay, so by using the derivative, what it's telling us is that if f prime, so if the derivative of x is greater than 0, right, for all values of x in your interval, then the function is increasing. Okay, but then the opposite is true for a decreasing function, right? So if the derivative is less than 0 for all x in your interval, then we say it's decreasing. Okay, without having to look at this definition. So you look at the derivative now instead of the function itself, okay? All right. So then if we look at a graph, right, we're going to look at the graph of x cubed plus 2x. So we're going to say f of x equals x cubed plus 2x. What that graph looks like is when x is 0, y is 0, when x is 1, y is 3. And then it gets bigger, so it looks like this. Negative 1 would be negative 1 minus 2, so negative 3. So it's looking like this, okay? So this is the graph of x cubed plus 2x. All right, then you can find the derivative, right? We have all of these tools for finding the derivative. So we can say that f prime of x is 3x squared plus 2, right? You multiply by the 3, subtract 1 from the exponent. Then take the derivative of the next part. So multiply by 1 and then subtract 1. So we get 3x squared plus 2. Okay, so then looking at the derivative, okay, you see that for any value of x, right, what happens to the derivative? If I put in a negative number, you square it and it's positive times a positive plus a positive. So when x is less than 0, the derivative is positive. When x equals 0, meaning technically the derivative is equal to 0. And then when x is a positive, the derivative is also positive because it's a positive number squared times a positive plus a positive. Okay, so what that tells us is that for all values of x, the derivative is positive because x squared is at least 0, and then, oh, no, I wouldn't put the included 0 here because 0 squared plus 2 is positive, okay? So this term is at least 0, can't be negative, plus a positive number. So the derivative of that is positive for all x values, okay? So then that tells us that the original function is an increasing function on the entire interval. So we write that as negative infinity to positive infinity. So, and you can get that by looking at the graph, right? You're always getting bigger, but using the derivative, that's how we would figure out that it's an increasing function for all values of x. Okay? We use the derivative because the derivative is generally a simpler form to look at. Okay. So, the converse of this statement, though, is not always true, right? So the converse is switching the if and then. So what the statement said was if f prime is greater or less than 0 for every value of x on an interval, then f is increasing or decreasing on that interval, okay? So the converse is not necessarily true, meaning the converse would say if f is increasing, then f prime of x is greater than 0. Okay, it's not necessarily true. So it we can summarize what we need then. Okay, so what it says is if f prime is greater than 0 for all x, then f is increasing. If f prime is less than 0 for all x, then f is decreasing. And if f prime equals x or equals 0, we can say the interval is, or the function is a constant. Okay, and that's kind of summarized. Bottom of page 236 for you. Okay, just using the derivative to decide if it's increasing or a decreasing function. Okay. All right. Second to that, is local maximum and local minimums. Okay? So we would say that if the first derivative of a function equals 0 for a given value of x, you know that the slope of the graph is 0 at that point. We're going to say x1, okay? Right, so then if f prime of x equals 0 for some given x, we're going to call it x1, then the slope of the graph at that x value is 0, okay? If the slope is positive just to the left and negative to the right, okay? So we're saying here's a 0 slope, okay? The graph has a 0 slope at this point. To the left, it has a positive slope and a negative slope to the right. Then we would say this would be a maximum. Okay? If the given function has a negative slope to the left and a positive slope to the right. Right, again, we're talking about here's our point that has a 0 slope. Okay? The graph to the right is positive slopes and to the left is negative slopes. We would say this would be a minimum. Okay? So, kind of to summarize that up, what it is saying is that you have a value for c. You're approaching it from the left at c and from the right. Okay? Then if the derivative of c coming from the left is greater than 0, the derivative at c is 0, and the derivative approaching c from the right is negative, this is a maximum. Then, for a minimum, what it's saying is that if the derivative at c coming from the left is negative, the derivative at c itself is 0, and the derivative at c coming from the right is positive, we're going to call this a minimum at c. Okay? All right. So, how do we use this with our graphs, right? So, one thing they could ask you would be to decide, given a graph, where the derivative is positive, where, if you know something about the derivative, what can you tell me about the graph, and then finding your maximum and minimums. Okay, so let's say you have the graph of a quadratic, okay? So say it looks something like this. Okay, this is the graph of f of x. What would the graph of f prime look like? Okay, well, So f prime is the slope, right? So right here, and kind of sketch this a little off. Let me move it a little bit. Okay, so to sketch the graph of f prime, you use slope because the derivative is the slope. So right here, it is a minimum, and so it is a slope of 0. So the derivative then says that at x equals 1, the slope is 0. Then going this way, right, when x, or actually going from the left, okay, you see that the slope of the graph is negative for all x less than 1. So f prime of x is less than 0 when x is less than 1, because this is a negative slope. Then f prime of x equals 0 when x is 1. And then this way the slope is positive, so f prime is positive when x is greater than 1. Okay? So to graph this, we know that f prime is 0, so here we are. Then when x is bigger than 1, it's positive, so it's going out this way. And when x is less than 1, it's negative, so it's like this. So this line is the graph of f prime because we're using the slope of the graph of f to get the graph of f prime. Okay? All right, then let's say you're given a function, okay? So suppose f of x is x squared plus 2x plus 3, okay? We want to use the first derivative to show that you have a minimum at x equals negative 1. Okay, so using the derivative, the first thing you need to do is take the derivative. So the derivative of f of x is 2x plus 2, right? Because the derivative of x squared is 2x. The derivative of 2x is 2, and the derivative of 3 is 0. So here is f prime of x. Then to decide if you have a local maximum or minimum, we're going to say, okay, we're going to let the derivative equal 0. So 0 equals 2x plus 2. Okay, solving for x, we get 2x equals negative 2, x equals negative 1. That's a good sign, okay? Because that tells us that f prime of negative 1 is 0. Okay? So because it equals 0, that means that negative 1 is either a maximum or a minimum. Right? Now we just need to look at what's happening to the left and to the right of that. Okay. So then here, we're going to decide what happens to f prime of x. So f prime of x equals 2x plus 2. When is this going to be positive, right? So when is this going to be greater than 0? So it's going to be greater than 0 when x is greater than negative 1. Okay, so then what that starts telling us is that f prime of x is positive to the right of negative 1. Now we need to see what happens to make f prime negative. Okay, so f prime of x is negative when? Well, doing this same step, we're going to say, okay, what values of x make x prime negative? So f prime of x equals 2x plus 2. We want to know when that's less than 0. So solve for x. So when x is less than -1, we get that the derivative is less than 0. So since the slope of the graph is 0 at -1, and it's positive to the right and negative to the left, we can say that this is a local minimum. If this was swapped, that would be a local maximum. Okay, so just using the derivative some more to analyze your graph. The slope of it, and then finding out if you have a maximum or a minimum.